Oddly enough, a taxi cab, a teacup, a jet, a crawler tractor, a fishing trawler with its engine and hardware, and a football all have something in common. These are just a few of the millions of items mankind uses every day that are made completely or in part on machine tools made by Kearney and Trecker. On all the continents, in countries large and small, Kearney and Trecker products are making vital contributions to mankind's standard of living. Our manufacturing facilities here and abroad have but one prime responsibility: to aid the metalworking industry to reduce costs and increase productivity. How well we will meet this challenge will have a vital effect on the continued economic growth of the free world. E.J. Kearney and Theodore Trecker entered the machine tool field in 1898 with a workforce of 12. Because Kearney and Trecker products have always lived up to their builder's promise, the company has grown to a point that today thousands of skilled employees produce the world's most advanced line of machine tools. The skilled specialists manufacturing our line of Milwaukee-Matics have more collective experience in developing and building numerically controlled machine tools than any single group in the world. For these are the men who actually pioneered this new age of metalworking. Through their efforts, the world's first numerically controlled machining center, the now famous Model 2 Milwaukee-Matic, was introduced to industry in 1958. For the first time in industrial history, workpieces made of all types of metals were milled, drilled, bored, reamed, and tapped in one setup under the absolute repetitive accuracy of tape control. While most other machine tool builders were struggling with only prototypes, Kearney and Trecker began actual installations of Model 2s in customers' plants. The world's first formal classes in numerical control operation and programming methods for machining centers were established for Kearney and Trecker's customers. The application of this proven, economical method of manufacturing was not to be limited to the size capacity of the Model 2 Milwaukee-Matic. It was soon evident that the metalworking industry needed this same method to machine larger parts. This demand resulted in the introduction of a larger Milwaukee-Matic, the Model 3. The automatic tool changer on this unit was designed to accommodate larger tools up to 6 inches in diameter. This remarkable new concept of manufacturing required new concepts of financing. Kearney and Trecker's management scored an industry first with the introduction of liberal lease and purchase plans for the equipment. A tool lease plan was developed and extended to run over an 8-year period with an option to buy. A cash flow purchase plan was also introduced based around the 7% tax credit and depreciation allowance. American industry of all types placed orders. From Sweden, France, Germany, the United Kingdom, and Australia came orders for the units. By 1964, over 300 machining centers were at work the world over. This undisputed leadership of Kearney and Trecker in the numerical control field is due to a very basic philosophy of management: a willingness to devote vast amounts of capital to research and development. Long before most machine tool builders even considered the problems of numerical control, Kearney and Trecker's management centered its research effort in this area. As far back as 1941, that's 17 years before the introduction of the first Milwaukee-Matic, Kearney and Trecker engineers made important strides in the efforts to control machine tools with previously programmed information. This research report, dated in September of 1941, gives the details on a project to develop an automatic machinist. The report stated,
in the laboratory, 2 forms of the automatic machinist are under development. First, an automatic machinist which will be guided by a mere drawing, the other being controlled by a punched tape.
A machine tool controlled by a punch tape, the Kearney and Trecker goal in 1941. This development engineer's notebook, which is now 25 years old, shows samples of the type of tape used in these early projects. As time went on, it became obvious that adapting tape controls to existing machine tools was not the final answer. Therefore, all research efforts for the next decade were concentrated on the development of specially designed machine tools, tools that could fully utilize all the advantages of this new machining method. In 1956, a significant government contract was awarded to Kearney and Trecker. This contract called for the production of 22 of these tape-control three-axis profilers to be delivered to the aircraft industry. These machines that are used to make aircraft parts were the world's first mass-produced milling machines designed especially for numerical control. The same government order called for the design and manufacture of 7 tape-control skin mills to be used for the production of complex wing sections for supersonic aircraft. The development of these machines, combined with continuing research, has resulted in the awarding to Kearney and Trecker the majority of basic patents pertaining to tape control machining centers. When the aerospace industry found it was spending precious time and facilities machining small-run, complex workpieces on conventional machine tools, Kearney and Trecker engineers were consulted. No single group of men anywhere were better qualified to apply the advantages of numerical control to this vital industry. The result was the 5-axis Milwaukee-Matic. The production of complex configurations became commonplace jobs on the 5-axis model due to the machine's maximum utilization of geometry. Through the application of a tilting table, all workpieces are presented to the spindle head. This method permitted the use of short tools for greater rigidity and accuracy. What had seemed an impossible dream of the metalworking industry had finally been achieved. To mill, drill, bore, ream, and tap in all 5 axes, at the same time, in one setup, under tape control. But Kearney and Trecker research is a continuing thing. The goal was now to adapt the Milwaukee-Matic method to solve the cost problems of less sophisticated job lot production. A decade of numerical control leadership and extensive research provided the answer. Even more startling than the very first Milwaukee-Matic was the introduction of the Series E. Now, the advantages of numerically controlled machining were available to automate the production of less sophisticated workpieces. This new machining center could mill, drill, ream, tap, and bore a whole new field of short-run jobs with repetitive accuracy. Another important milestone in metalworking had been realized. A great cost-saving factor is the ability of the Series E to machine several sides of a workpiece in a single setup. Only a horizontal spindle, working in conjunction with an index table, can provide this degree of flexibility, a feature found on all Milwaukee-Matics. Once again, production models of the Series E were actually at work in the Kearney and Trecker plant before the news of this development was released to the trade press. Today, in shops throughout the United States and in major foreign markets, various models of Milwaukee-Matics are at work. This acceptance is dramatic proof of this concept's ability to solve the problems of high-cost production anywhere in the world. As the world works with Milwaukee-Matic, so does Kearney and Trecker. In our own modern plant, these machining centers are producing round the clock. Every advantage of the Milwaukee-Matic method of manufacturing is utilized to produce the high-precision components that continue to make the name Kearney and Trecker a byword for extreme dependability in machine tools. For example, the giant Model 5, now a part of our product line, was initially designed to produce large components, such as the one-piece solid back columns for our line of knee-type milling machines. The Kearney and Trecker knee types are marketed in over 70 variations of 3 basic models, each designed to meet various machining requirements. Over 75,000 of these dependable units have been delivered to customers. This represents a substantial percentage of the free world's market for this type of machine tool. The repetitive accuracy of the Milwaukee-matic method is also applied to the production of parts for our line of Milwaukee Mill bed-type milling machines. Hundreds of types of precision parts for all our products are also machined on these unique Kearney and Trecker rotary head milling machines. The die industry has long depended on these units due to their ability to machine any geometric shape in both the horizontal and vertical plane, in most instances in a single setup. The design and manufacturing facilities of Kearney and Trecker are also playing an important part in supplying the free world's industries with specially designed machine tools. Chances are this construction worker never heard of Kearney and Trecker as such, but one of our specially designed machine tools was a vital link in the manufacture of the crawler tractor he's using. A fully automatic, numerically controlled traveling head milling machine was designed by our engineers to economically machine long, unwieldy crawler tractor frames. One machine and one setup did the work formerly run on many machines and many time-consuming setups. It's very possible that Kearney and Trecker machine tools played an important part in mass-producing the engine of this taxi. Kearney and Trecker engineers have been responsible for the development of many special machine tools for the world's automotive industry. For instance, this high-production 4-station rotary transfer machine was designed to automatically mill and drill steel crankshafts. Another Kearney and Trecker development successfully automated the drilling and tapping of differential covers and castings. This machine drills, bores, counterbores, chamfers, reams, taps, and trepans. In the Kearney and Trecker plant, millions of dollars of the very latest facilities are available to produce any type of special purpose machine tool. One of the major reasons the world's industry turns to Kearney and Trecker so frequently is the craftsmanship of our employees. The majority of our machinists, assemblers, and electricians are graduates of a 4-year apprenticeship program, which was established as early as 1901. These are the men who are called upon to build some of the world's most complex machine tools. Machine tools for the aviation industry, the electrical industry, agriculture, ordnance, petroleum, printing, textiles, and appliances, just to mention a few. We have now seen the line of Kearney and Trecker products employed by the world's industry to produce the millions of items used by mankind every day. Teacups, footballs, tractors, jets, cars. Most anything you come in contact with was made completely or in part on machine tools, and perhaps on Kearney and Trecker machine tools. And there is no end to this narrative, for the story of our products is the story of mankind itself. The proper application of modern machine tools by the free world is now, and always will be, the very foundation of our wealth, well-being, and security. To remain free and independent, we must have the facilities to properly machine new metals, vital for our defense and aerospace needs. These critical requirements demand new applications of Kearney and Trecker's experience and facilities. The knowledge that produced the Milwaukee-matic age of manufacturing is being applied in a variety of ways to help futurize an ever-increasing number of industrial operations. Significant additions to the group of Kearney and Trecker products are now on the drawing boards, and others are in the testing stage. Soon they will join the thousands of other Kearney and Trecker machine tools now at work. Where do you find Kearney and Trecker products? Anywhere in the world. valve bodies, manifolds, gear housings, regulators, pump components, fuel systems parts, motor bases, prototypes of all kinds. These are just a fraction of a vast array of parts being produced on this astounding, numerically controlled machining center. It has long been the dream of the metalworking industry to mill, drill, bore, ream, and tap in one setup automatically on a single machine. To fill this vital gap in our technology, Kearney and Trecker Research developed the world's first automatic multi-machining center, the Milwaukee-Matic. Since its introduction, the Kearney and Trecker Milwaukee-Matic method has created an entirely new concept in production strategy. The major effort of our continued intensive research into the field of automatic machining has been directed toward developing maximum versatility into this unit. And that's the reason we're with you now, to demonstrate the increased capability of this new version of the Milwaukee-Matic. New features on this machine now make the benefits of tape-controlled automatic machining a practical reality in many new areas in the metalworking industry. Milwaukee-Matic is now equipped with solid-state numerical controls, proven in the field to be the easiest and most trouble-free methods of controlling machine functions by tape. The control brain is transistorized, a major breakthrough for trouble-free operation. Because these components store tape information in advance of actual machining operations, there's no waiting time for tape reading. Modular construction provides rapid accessibility for routine maintenance. A unique card tester checks out modules in a matter of seconds. This fault finder device instantly analyzes over 40 circuits and pinpoints possible trouble. A continuous red light indicates all conditions are normal. Plug-in type relays allow fast replacement. And test tapes are available to pre-check the machine control. It's significant to note that this solid-state control permits the machining of complex part configurations without the use of a computer. For example, contouring, so important in prototype work and hundreds of other applications, is now routine. This new Milwaukee-Matic, of course, has the standard features that have been proven in the field since 1958. 961 different tool codes can be recognized by the machine. To mill, drill, bore, ream, and tap just about any part configuration made of just about any type of metal. There's plenty of spindle power to hog out rough cuts. However, the same spindle can also handle finishing cuts. When a tape command for a tool change is read by the tape reader, the new tool is in position in less than 8 seconds, ready, in this case, to perform a contour milling operation on the same workpiece. This boss is being machined by the contouring action of the horizontal and vertical slides of the machine. All contouring operations consisting of arcs and slopes and any 2 of 3 axes can be programmed without the assistance of a computer. The command on the tape now calls for indexing the workpiece 90 degrees to be in position to contour a large arc. The machine is capable of milling radii up to 100 inches. The tape now directs the machine to index the workpiece 270 degrees. Milwaukee-Matic is available with either of two types of indexing tables. Standard with 8 positions and optional with 360,000 positions. Perhaps you're wondering what is involved in actually preparing a part for production on Milwaukee-Matic. The pre-production requirements are fast, economical, and simple. Blueprint information is converted to a numerical control manuscript. The programmer prepares the entire operation, selecting machine positions and tooling data, including feeds and speeds. Manuscript information is then transcribed on a flexor writer to control tape. This 1-inch wide, 8-channel tape has a binary coded decimal format. At the same time the tape is being punched, all tools for the job can be preset and coded. This Kearney and Trecker precision tool setting device uses an optical system to locate the established length and diameter. While Milwaukee-Matic itself is completing one part, an entirely different workpiece can be readied on Polycheck, a machine simulator. This is an important step in reducing non-productive machine hours, tooling costs, and lead time. At the opening of this film, we highlighted just a few of the vast array of parts being manufactured on hundreds of Milwaukee-Matics all over the country. The reason for this widespread application is the machine's ability to perform a variety of operations. For instance, all types of drilling can be performed, including deep hole drilling. Precision boring operations can be accomplished without special setups. Imagine what this would require with conventional methods. Because of the positioning accuracy of the machine, no expensive jigs are required for reaming operations. And tapping of any size is just another standard operation commanded by the tape. Here's further proof of maximum machine utilization, right on the job. Parts of different sizes and shapes can be intermixed and processed with no loss of profitable production time. While Milwaukee-Matic continues to manufacture one part, the operator places an entirely different job on the shuttle without pause or interruption of the machining process. Preset tools for the changeover can be inserted into the magazine while the machine is running. They can be placed in any position due to a patented coding system. A tape for the new part is inserted in the reader and the job is ready to go. When the part on the machine is completed, a tape command automatically unclamps the pallet and simultaneously shuttles the finished part off and moves the new part onto the index table. When the new part is in position, the machine control unit switches to the new tape and begins to respond to the new programming. Milwaukee-Matic is the only machine tool that fully utilizes the profit potential of numerical control. What you have just seen has upset the old established theory of economic lot size production. Make 1, make 10, make 100. The machining cost for each part remains the same. Up to this point, we've talked primarily about the hardware concept of Milwaukee-Matic. Now let's consider for just a moment the management fringe benefits this method offers. For example, floor space. One machine does the job of many. When your company is faced with the need to expand, the saving of floor space can contribute measurably toward justifying the purchase of the Milwaukee-Matic. Inventory. The Milwaukee-Matic method greatly reduces the tie-up of your money in partly finished workpieces. With this machine, inventory may actually be reduced to a roll of tape. Quality control. Because of the precision built into Milwaukee-Matic, Parts can now be produced with extreme repetitive accuracy. This reduces inspection and assembly time. Tooling costs are reduced to a fraction with the Milwaukee-Matic method. Savings in this area alone may pay for the cost of the machine in 1 to 3 years. Lead time. The conventional process of moving parts from one work center to another is time-consuming. Milwaukee-Matic manufactures parts as needed, in one place. The present policy of manufacturing to an inventory level can be changed to manufacturing to order. For years, your industry has relied upon machine tool builders to provide improved metal removal techniques. With Kearney and Trecker Milwaukee-Matic, the technique of the future is here, now. Milwaukee-Matic is bringing the benefits of tape-control automatic machining to ever-increasing areas in the metalworking industry. Through automation of job work, hundreds of companies are gaining significant advantages over their competition. The Milwaukee-Matic method of manufacturing is changing their production months into minutes. How long has it been since you visited a museum? A few hours in one can be very revealing. It gives you another perspective on our contemporary society. For instance, not too many years ago, this was the filling station of the true age of horsepower. And here, at the turn of the century, was an up-to-date drugstore, complete with a supply of leeches. Less than 100 years ago, this primitive medical concept was still being used. In the study of the natural sciences, we can hardly overlook the huge dinosaur. He weighed many tons, but his brain, oddly enough, was about the size of a pea. But not everything in a museum is old, at least in terms of numbers of years. This is the famous Gemini 7. It's already a museum piece in this split-second age of lunar exploration. Yes, there's much to learn on a visit to the museum. Lessons not just for school children and historians, but lessons that can be applied to the modern business world. Watch this.
Yes, Mr. Orton. I'll take care of those letters this morning. And I'll call the airport about your flight.
Good, good. And Jane, get George Merrick at the Denver plant on the line, will you?
Yes, sir. Oh, you mentioned yesterday that you wanted a conference call with Mr. Merrick. And the plant managers from Seattle and San Diego. Now, is that still on?
Yes, yes. Say, I'm glad you remembered. Secretaries like this are hard to find. Yes, of course. I want all the West Coast boys in on this deal. Thank you. Okay, Pete. Now let's get back to the plans for the new Texas operation, shall we?
Right, J.B. Now, our people have designed this facility to be the most modern setup of its kind. For instance, take a look at this floor plan. Ideal for materials handling. You know how you have to move your parts from one machine tool to another without cluttering up the aisles.
Yes, moving work pieces is one of the big bottlenecks in our present plans. I'm glad you're planning for it.
Look here at all this space for warehousing and inventory right at the plant.
Warehousing. Yeah, that's a necessary evil of our business. I wish somebody could figure out a way to make that space more productive.
Yeah, you're right, J.B. You can't make parts in a warehouse, but what are you going to do? You got to have that space for storage.
Look, Pete. Right now, we're bidding on this job. You know, in our business, the part's the thing. And if we can't make them fast enough, that's the end, brother.
Well, that doesn't look too difficult to turn out.
I'm sure this new plant will handle it. Well, it's a lot more complicated than it looks. That's when all those wide aisles you've designed come in. You see, we've got to run this job through our lathes to get the turning done. Then we've got to drag it around the shop for the milling, drilling, boring, and tapping. You see, Pete, it's a good profit maker. if we don't kill ourselves with all those setups.
JB, your new plant has the best materials handling setup I've ever designed. Now, when you're producing a part that has to be moved from department...
In many ways, this office and the people in it could be a display in a museum, too. Of course, it doesn't look much like the ones we just visited. But appearances can be deceiving. The president of this company, JB, is a highly respected